So today is Wednesday, May 12th in the year 2021, and this is Get Smarter and Make Stuff. I am really pleased to welcome to the show today a guest who I think will have a lot of interesting things to say on our two major questions, because I've run into him before and professionally, and we've always had a good time talking about making stuff and about learning and that kind of thing. So I'm referring, of course, to our guest today, Mike Fikes. It's great to have you here.
Hey, Craig, how you doing? Yeah,
Good.
good meeting you.
Yeah. No, so we have had done podcasts before because we both kind of lived in the Clojure space, right? And so it's good to get you back on here, and we're going to talk about other stuff, not Clojure. Although we can talk about Clojure too, that's fine.
But, it'll be hard to resist that, I guess. Yeah.
Yeah, no worries. No, that's cool. No, actually, I've know a little bit about what you've been working on, and it's really cool that that's involved. I don't mean to discourage you from talking about that, but it's great. It's good stuff. So anyway, sorry to step on you there, but I think I told you. I think our listeners will know that we really only have two questions on this show with a bonus one at the end, which goes something like, let's talk about making and let's talk about learning. Mm-hmm. I think you've got a lot to say about that. So, what you've been doing, man? What's on your learning and making plate lately?
Yeah. So this whole thing is about electronics, which for me is heavily about learning, because that is not my identity. It's actually started becoming my identity, but it was like a steep uphill mountain to climb in terms of learning all the stuff that you need to learn. In the sense that, it's almost like there are things where you feel like you might be excluded from doing certain things if you don't know enough about it. And electronics has always been one of those things where the danger of high voltage keeps me away from getting anywhere near that kind of stuff,
Sure.
But even just like normal, like the electronics we're talking about is more like low voltage stuff. Even that has always been opaque to me. And I don't know why, but it's just been, I think it's because you can't see electrons. And I've always been I was a mechanical engineer. I was always more like, I'm a simple-minded guy. I basically understood things I could see and touch, and even I think it's probably true for people who get into electronics that they will admit that a lot of the stuff that goes on in circuitry and whatnot is very abstract, and you have to come up with I don't know what the right word is, but like parallels or ways for you to think about these things and understand them that matches up with your intuition that you might have built.
Mm-hmm. Yeah, no, I know what you mean. I've been doing a little bit more electronics myself. I not technically, I do have a degree in electrical engineering, right?
Yes, that's true. So you were course 6.
Yes, for those of you that are...
who don't know,
right?
Who aren't in the know.
Yeah.
And I was course 16.
Right. So we both went to MIT, and at MIT, everything's a number. The buildings are numbered. The majors are numbered. Yeah. So course 6 was double E. Actually, it's double E and computer science. And course 16 is
it's
aeroastro. Yeah, aeronautic. Yeah. You're a rocket scientist or a rocket engineer, I suppose, right?
Oh, that was awesome, because Draper Labs is there next to MIT, and that's where they did the Apollo guidance and navigation stuff. Was right there. So it's like it wasn't like the rockets themselves. It was the guidance computers and whatnot. Mm-hmm.
Yeah,
cool,
right.
Cool stuff was there. Yeah.
All of which, of course, would run on an Arduino times 1,000, right?
Yeah.
So anyway, I know what you mean.
Yeah.
When you talk about electronics being a bit of a foreign land, I have to laugh when I sit down at my bench and try to do electronics because, like I said, I have a degree in double E. My focus was, signal processing, so it wasn't electronics. But I'm clueless. I'm really clueless. I'm picking up a soldering iron. I've been working on this project, the electronic lead screw. I've got a few videos on my YouTube channel.
Yeah.
And my soldering is horrible. My electronics is horrible. I tried to hook a function generator up to my stepper motor the other day, and I thought, oh, this will be great. It'll turn it, and it didn't turn. And I have no idea why. So I understand completely what you're saying.
Well, you could argue there's this whole theme about what you learn in school is like a bunch of Laplace transforms and stuff,
right.
Or a bunch of math, basically.
Yeah,
and it's good, but it's also there's a whole nother side to things, and just a pragmatic knowledge of how to use the things that exist in our world to cobble them together to make stuff. And a
Mhm.
lot of it has nothing to do with math. It's
Yeah.
just experience and doing a little research and learning, like, what are these things? How does a soldering iron work?
Right.
Yeah.
When I was doing my degree, I did an internship program, which those of you that are familiar with MIT might know as 6A. Anyway, it doesn't really matter. But
Mhm.
I was at a defense contractor at the time, L'Oreal Infrared Imaging Systems. They've since been bought twice, whatever.
Mhm.
But what was really interesting to me was that when I was there, I was working in the electrical engineering department, and I would work with the engineers. But I was also exposed to the technicians, and these were two pretty
Mhm.
separate career paths.
Yeah.
And they were, what was interesting to me was they were both really, really good at what they did. The engineers were good engineers, but the technicians were really good technicians. And it was stark that you needed both of those things. And so, like, the engineers would come up with the design, but the technicians would build it and service it and repair it and actually make it happen. And you had these guys. There was all guys at the time
Mhm. Yeah.
who'd been there for 30 years and who could fix anything or take one look at the design the engineer had brought down and said, no, you need another capacitor right here, or that'll never
Okay.
work because of this reason. And I think it gets a bit to what you're saying about how, the theory is important, but that there's all sorts of practical knowledge that you need to acquire as well.
Yeah. Maybe it's a whole spectrum, because even engineering is sort of like in the middle there somewhere, where you have like just the pure math and pure science, or
Sure.
like an engineer is someone who uses all that and applies it to the real world. But yeah, there's it's a whole spectrum, really.
Yeah.
Yeah.
So what have you been working on? You said it's electronics, but
Okay.
like, what have you been
Yeah.
working on?
So what got me kind of hooked into this stuff? So I identify as a software developer. I've
Hmm.
always done it. But I've never really understood or thought deeply about how computers actually work. And I always thought, it's obvious. There's some gears in them that turn, and the calculations get done. But there's a cool set of videos by this guy named Ben Eater, and he actually goes through and teaches you kind of at the logic gate level, almost down at the transistor level, of how you can build up a computer. And for me, that was that was enough of a hook, because it's kind of related to software, computers and software. But it was like, what really had the light bulb go off in my mind was when he got to the point where he explained how computers, how the microcode and CPUs actually uh, works in order to make like the fetch cycles and the instruction decode cycles work.
Hmm.
And he it's like, typically anything that you don't understand is kind of mysterious until it's explained to you, and then the magic goes away. And you're like, oh, that's how it works. And then you're like, now I understand computers now. But going down that path, a lot of that is just like straightforward, just electronic stuff. And at that time, like I said, for me, it was always opaque. And I knew, like, I think, like a lot of people who go through just regular education, you learn about like what resistors are and what voltage is and whatnot, and you learn how to do like the parallel versus series resistance formulas and stuff like that. So I knew that kind of stuff. I think a lot of people know some rudimentary stuff about electronics and how to reason about them. Um, but for me, with the Ben Eater stuff, it was like, okay, let's get some breadboards and actually let's plug in things into it. And that's where you learn little things like the fact that like an LED needs a resistor hooked up to it in series with it, so that the LED doesn't basically burn out. You
Hmm.
need
Hmm.
something to limit the current flow. So that's how little my knowledge was. But I was hooked. It's basically, I wanted to like explore this, and for me, it was largely just like a side hobby, just like learning. You know, what are these things? What is a voltage regulator? And it's fun because you can just kind of experiment, and it gets you away from my world of like doing software, which is all mental exercises. It's kind
It's
of like I
so
can hook stuff
interesting.
together with my hands.
It's so interesting that you say that. You are the, I think, third of, at this point, four guests, fourth of fifth, something like that. The majority of our guests have all said this interesting thing that I do on the side to make and learn. An important aspect of it is that it not be what I do for my job, that it be different.
Yes. It's like, yeah, it's the typical thing. Like, you sit in front of a computer all day. Last thing you want to do is go like oh, I want to simulate a circuit. No, I want to actually build a circuit on a breadboard and see it, do whatever it's going to do. Yeah, it's it's a mind shift. Yeah.
So so when you were, you're like, this is all interesting. I want to learn about this. Like, what did you do? I've been reading a book called The Art of Electronics, which has been highly recommended. At least I forget where I came across it, but it was highly recommended somewhere on the internet. And it's quite good. It's taking me back to my double E days. I'm curious what sources you found useful when you decided to learn about electronics.
Yes. So that particular book I have as well, The Art of Electronics. And with it, there is a kind of like a lab series that goes along with it. And the way, I can't remember the author's names, but the way they explain that book is that they were trying to teach scientists how to cobble together electronic circuits just to do things that they needed to be able to do in their labs. So there's another whole like book that accompanies that book, and it takes you through like from a practical perspective how to put together just it starts off with the rudimentary stuff of how do transistors work. Like I knew that transistors have 3 legs, right? That's about all I knew. It's this thing that has 3 things sticking out, but it's like the emitter, base, and collector, and you start getting into all those things and actually starting, you mess around with them in these labs, and you build little amplifiers with them, emitter followers and whatnot. It's I find sitting down and actually making those things, for me, I can read about something in a book and I can understand it to a certain level. But then when I go and I make the thing, I realize there were a lot of aspects I didn't understand. So that book is great because it actually provides you with enough things to try, and it's almost like, here, make these things, and let's think about what these consequences are of this aspect of this thing. So that to me is a really good book.
So I'm curious though to dig in that a little bit more because we talk about learning and making. I love the intersection of those two things. So what I'm curious to ask about like the degree to which making alone would have been sufficient, or reading. I mean, you said reading was fine, but making was really important. Would you have pursued an avenue where you just made things and kind of figured it out, or is it always the case that you want to look for kind of the academic side and then the practical side, or how do you intend to go after that?
Oh, so I think I'm kind of, maybe I'm kind of lazy and I just want to make something, and then we've all probably been there. You're making something and you're like, why is this thing not working? And it's like, just kind of write out an equation that describes the thing and then solve that equation. And that it's the tip. It's called analysis versus synthesis, I guess. Like you're like trying various experiments, trying to get it right. And you're like, if I just write this down, I can get to the answer more quickly. So for me, I've always just been the kind of person who just likes to make stuff. And the academic part helps reason about it and, basically come to the solution. But one thing I would say, I've particularly seen this is true with electronics, is that you often learn the most when things don't work. And I've heard other people say that too. And I guess that's probably true with software as well. But you just don't see it as much because the iteration cycle might be so much more quick with software, where you're always things aren't working, right?
Yeah, things are
with
software.
software.
I was going to say, yeah. Yeah, it's the normal state. Like the point where it's not working is 90%, 99% of the life cycle. Yeah.
So you're always struggling to just get it to work for the first time with software. Yeah. Whereas with electronics, a lot of times the constructs you're using perhaps are a little bit simpler. You have a few resistors and some wires you're hooking together and an LED or two, and things. I don't know. Sometimes they tend to work more frequently, but you don't learn anything when it does work other than, okay, yeah, the thing you thought was true happened to be true. And when things don't work, that's when your gears start turning and you're like, okay, why is this not working? What aspect did I miss in my understanding?
Right. Where's the noise coming from?
Where's the noise coming from? Or was there some subtle thing that you're just seeing that just happens to be glossed over in the books, and you're like, oh, really? Okay. So for me, that's a big part of all this, is just like making things and seeing that it doesn't work and then learning from that. And it's almost like you want it to break. You want it to not work so that you have an opportunity to learn what's causing the failure mode.
Mm-hmm. Yeah, totally. I mean, not. I mean, yes,
Mm-hmm.
I agree with you completely. I will say I'm in the phase of my current project where I am ready for it to just work.
Yeah,
Like
exactly.
I've made a bunch of mistakes, and I'm like, okay, I think I've learned a lot. But no, you're right. What you're reminding me is that what I should do is say, okay, well, you're either going to get it to work, or it's not going to work. But if it doesn't work, that's okay because you'll make it work, and in the course of doing that, you'll get smarter, right? So it's
Mm-hmm.
okay either way. So,
Yeah.
so
Yeah.
we've talked
Mm-hmm.
we've talked
Yeah.
about the fact that you're into electronics, and I think I kind of sidetracked you a
Okay.
couple times. What are you? Is there like a particular thing that you're making right now, or are you just sort of trying to bootstrap your way from transistors to computers, or what's your pursuit?
Okay. Yeah. So it started off for me as kind of like just an interesting side hobby, just because it's fun kind of thing, and
Hmm.
then it became something that actually started to become valuable at work, which surprised me. I never expected that I would actually start doing things at work with this, because I was working at Vouch, which is a software company, right?
Hmm.
And the reason that happened was we were giving some demonstrations to an automaker of something that we had built, and I actually had put together something with a breadboard we're basically making a digital lock, or something that would unlock cars, and
Hmm.
we were effectively demoing our software with a little breadboard thing on the side, making some LEDs light up, using like a Raspberry Pi, um, and the feedback we got was like, yeah, that's cool, but it's kind of like, something that someone in high school would make, a breadboard thing. What you really need to do to like, and that's, this is about where my knowledge of electronics was at the time. I said, what you really need to do is you need to actually make something that really unlocks a real car. You need to go plug it into a real car. Um, and I'm like, okay, that's the next level up
Hmm.
in terms of like reaching for something cool to do. So at that point in time, what we did was we reached out to Bill Hurd, who was that he actually designed some of the Commodores back in the day.
Oh wow.
He actually, and it was surprising. Like, oh, what the hell? We'll ask him, would he be willing to work with us? And he said, yeah. And the reason we did that was he had practical experience, of course, of making real electronics with PCBs and whatnot. And he helped us, and he became my mentor, basically brought me to this next level of basically moving from breadboarding things to actually making things with PCBs, and learning, going from like doing like through hole kind of stuff, where you're basically putting resistors through the holes and soldering them on, to moving towards actually doing surface mount stuff where you're actually using CAD software to actually design your PCBs, have them printed, and all that kind of stuff. So for me, it was like, whoa, wow! It's like the floodgates turned on when we got Bill involved. Um,
Yeah, so I would imagine that the first time you made a PCB of your own design and had it, I haven't gotten to that point yet myself. Like I have a thing where I'll probably wind up having to do that, but I would imagine the first time you did that, it must have been a bit of a rush.
yeah, so there's I was at that point, and I can still remember being at that point where I would look. There are these online PCB printing houses that you can look up. Like JLPCB is one of them.
Hmm.
There's another one named Osh Park, and you can go online. You can say like, oh, it's fairly inexpensive to print a PCB. Like maybe like $5, whatever. Sometimes the shipping is more than the PCBs,
Right.
but it's like intimidating because all the jargon and all the choices you can make. Um, it's overwhelming, all the things that you might need to do, and you might think, oh, how am I going to even design the traces on the PCB? And in my
Hmm.
mind, I was thinking, oh, really, it's just a picture, right? It's a graphical thing that you could just draw it on using a drawing program, right? And I think
Right.
you probably could if you really wanted to. But there's, of course, there's a whole there are tools that you can use to properly lay out PCBs, and those tools also let you work with things from like a schematic standpoint, where you're laying out the schematic. A schematic is basically, just a high level logical representation of your circuit using, symbols for the resistors
Gotcha. Right.
and yeah, capacitors and whatnot. And these tools in particular, if you lay out a schematic, the tools then kind of hook into the PCB layout and make sure that like what you're drawing effectively in the PCB layout tool electrically makes sense. That all the things that are connected in the schematic are also connected in the PCB. But that whole journey. I don't think I could have easily have made that leap myself, or at least that quickly, without having Bill as a mentor to just say, hey, here's how you do this thing, or here's how you do that thing. Because that is a very steep hill. But once you've it's like anything else. Once you've been down that journey, down that path, like, this is actually not that complicated in the end.
Yeah, isn't it funny?
It's like
right,
everything's that way, right?
Yeah, yeah. I do. I mean, to state the completely obvious, YouTube is amazing, right?
Yes,
I know you didn't go that route, but I feel like I don't have Bill Hurd to be my mentor, and that's true for most of our listeners as well. But I do have YouTube, which is unbelievable, and I'm sure there's a series out there somewhere just waiting for me to trip over that will bring me up the hill, as you say.
No, I consume lots of YouTube. That is a great way to learn. It's kind of like this double-edged sword. You have to avoid watching the silly stuff on YouTube and pick the stuff that will educate you, right?
Mm-hmm.
and that's how I learned about Bill Hurd. It was like I was like looking at how do you do this, and like ran into some of his videos. So I am there too. I learned lots of stuff through YouTube, and there's lots of great content from people explaining. It's they're doing this just for fun, and you can. You can see that, you can feel the joy when they're explaining how to do all these things. But that's I probably have learned more through YouTube than from reading books, to be honest.
It's amazing, isn't it? Yeah. I mean, I say these things and I'm like, yeah, everybody knows this, but I still have this feeling, that when I kind of discovered, I'm using air quotes, discovered YouTube a few years ago, and people said, oh, there's YouTube videos. And then when I really sort of started dipping into it and just realizing the breadth of unbelievable information and depth of information that you can go on there and learn seemingly anything, and these amateurs are producing like stuff that you would have needed a television studio and a crew to do 20, 30 years ago. It's just unbelievable.
Yeah, there's one guy in particular, Alan Walke, who is I believe he's like a field technician or field salesman at Tektronix. And he knows his stuff, and he takes the time to explain it all on YouTube, to the point where he will start off by just kind of like drawing some stuff out on paper and showing you the circuit and showing you some of the equations that go with it without getting too deep in the math, but just kind of showing you that. And then he'll go over to the bench and he'll say like, here, let's build this thing on the bench. Let's look at what it does. And he is really good at explaining things, to the point where you'll see people commenting on his videos. It's like, man, I wish my college professor was as clear as you. He just has a real knack for explaining things.
I was just thinking about that, actually. The fact that, I'm sure you did. I certainly had some really great professors, and I had some terrible ones, because they're not really hiring for ability to teach.
Yeah.
Right.
Yeah.
But YouTube, it sort of automatically selects in a way, right? Like for people that are both knowledgeable and whose didactic technique is solid, or they're entertaining, which I did a professional education for a while. I taught programming short courses. Yeah. And like what we discovered was that in terms of getting good ratings from your students, it's actually more important to be entertaining than informational. We strove to be both, but like if you got out of a 3-day class and you were funny a bunch, your customers were going to be happy. We also actually, like the place I was working for did have very high standards in terms of, what you were supposed to deliver in terms of information, but the point being that like, there's a certain something, charisma or whatever it is, stage presence, whatever, something that you really need both of to be really good at. And, some people have it and some people don't, right?
So that's what I've been doing with electronics is I largely will watch YouTube videos because they're entertaining, and these people are teaching stuff about electronics, and I just learn as a secondary side effect.
Right. Yeah, totally. Yeah. Absolutely. So did we, I mean, we kind of talked a little bit about how you wound up making things that were useful for work, but is that I feel like when I was looking at your Twitter feed, there's other stuff you've been working on.
Okay, so the one thing that I did make is this ClojureScript board. So at work, since we're working on like basically putting things into cars and whatnot, you end up dealing with like, okay, I have to deal with microprocessors. But at work, Vouch is basically a closure shop. Now we want to do things that way. But typically with microprocessors, you tend to like basically program in C, basically. But I wanted to see if I could get Clojure or ClojureScript running on one of these MCUs, which is a crazy thought. Yeah,
it is completely insane. I know not all of our listeners are programmers, but trust me, this is very, very weird.
So why do you think it's insane? What do you think would cause it to fail?
I know that people have done similar things, right? So I know that it can be done, and
it is insane, by the way. I'm not
right. But it is sort of. I'm trying to think of a good analogy. It's like it's a very high level language, as we might say.
Yes,
but it's in a very low level environment. I'm trying to think if there's a good. I'm not coming up with a good analogy. Like I want to have one that's like. Go ahead.
It's a very resource constrained environment.
But I was trying to think if there's an analogy like with human languages. You know what I mean? Like it's so one way I think about it sometimes is when I talk about programming languages to people, I'm like, well, imagine that you're trying to get a 2-year-old to accompany you on a shopping trip, and the way you do that is you have to say things like, okay, come over here. No, come over here to me. Okay, now sit down. No, sit on the stairs. Now pick up your foot. No, the other foot. Okay, hold your foot. I'm going to put the shoe on, right? And so it's very, very detailed, right? And that's sort of the land that you live in with a microcontroller, is that you have to be super explicit about exactly what is happening. Raise this pin from, the ground to high logic level type of thing, right? And then if you think about high level languages, it's like taking your teenager where you say, go get in the car in 15 minutes. We're going to the store, right? And that's all you have to say. It's very terse. It's very concise. And the thing that happens is what you wanted to happen, but you're operating at a much higher level. And that type of description is when we use languages like Clojure that are higher level than languages like C, that we're operating at that level. So to put the two things together is kind of an odd, you know what I mean? Like you have this language whose intention is to be, go get in the car, running in an environment where all of the operators are take one step forward, now take another step forward, and then sit down. You know what I mean?
Maybe another way of saying what you're saying is like, if you had to like write an algorithm that was doing a lot of bit manipulation at the bit level, you might find it a little tedious to do it in a very high level language that doesn't have like first class support for bit operations, I guess,
Sure.
Or you can do that all in Clojure, but maybe maybe that's a way.
You're dragging along a lot of stuff, right? Like you're bringing a, you're almost like swatting a fly with a bazooka kind of thing, right?
Oh yeah.
So, but you decided to do this, which is super interesting.
Yeah, because if you could pull it off, like what we want to do, at least at work, is we just want to like extend some of our logic into this small corner of the world, the microprocessor, and just have it, or microcontroller, just have it running in there. Because what we have like certain things that we want it to do, like check certain things to see cryptographically if things are correct or whatnot. And all that stuff is like, it's almost like, it's just logic like anything else, really.
Sure.
And when it comes, so I guess that maybe for our particular problem domain, we're not so much like, oh, set this line high and set this other line low. It's more just like, we have some of the logic that we need to run there and that spot.
Sure, you've already written it in English. Why should you have to translate it into French?
Yeah. So the crazy thing about trying to get the stuff to run there, though, is mostly the amount of RAM that you have available.
Right.
It's not so much the computational speed, because that is a problem. These things are slow too, but it's really like the RAM is like the thing that will stop you. It'll be the no-go, the showstopper. But it turns out that some of these microprocessors, there's one called the ESP32 that, oh God, I can't remember.
We just talked about that on Russ's episode, actually.
Oh, you did?
Yeah, and briefly, he mentioned that he's been into it too. He mentioned it as a cool little board or set of boards, I suppose.
Yeah. So it's got like an insane amount of RAM in it. I think it's like a megabyte or something. Whereas instead of kilobytes, you're up in megabytes. And that's enough to, it's got enough to actually host a ClojureScript REPL. And I know a lot of your audience wouldn't even know what that means, but it's like the runtime for this language can actually fit in this small, tiny thing, and it can actually run, and you can jack into it and have a live REPL into it. And that's all about how much RAM these things have, really.
So I'm curious to get a little bit technical. Did you wind up writing? Because one way you could go about this is you could use something like I think it's Chicken Scheme is one of the things out there that compiles from Scheme, which is a language like Clojure, pretty similar actually, into C, which is a lower level language that you can then typically compile into
native.
Something native. Yeah. Or there's also Ferret or something like that. Ferret,
yes.
Weasel, some sort of rodent. I forget.
I know what you're talking about. Yeah, I can't remember what it is. Yeah,
it's another kind of I'm going to write in a very high level language like Clojure, and it'll turn into code that can run on one of these low level devices, a microcontroller or whatnot. So did you do that kind of thing where you wrote a compiler that was translating the code that a human wrote into or is there some other thing where like you have an interpreter that's kind of looking at things one step at a time?
So what you just described, I think in my gut, I think is the right way to do it in the end is, just for performance reasons.
A compiler?
I think so. I think anything that would generate native code in the end for these really constrained targets is probably the best way to do it, because you really are dealing with like almost no RAM, almost no CPU. But what I did instead was there is a project called Esperino, which is effectively a JavaScript interpreter. I want to say it's an interpreter, but it's a JavaScript environment that runs on microcontrollers.
Okay.
And it actually runs, it's fast enough. It has like its own JavaScript REPL, and you can get into it, and you can like, it reminds me very much like it. When I was a kid, you could get these like basic computers, Phil Hurd, back in the day, you'd get these computers and you'd flip them on and you could like program them in BASIC to do things, and they would respond on a human timescale quickly enough for you to interact with it.
Sure. 10 print hello, 20 go to 10. Yeah, the classic, right?
Exactly. Yeah. Well, the Esperino stuff is like that or faster, these days. So it can do stuff, right? Like some of these microcontroller or whatever, some of these problems don't have to, you're not doing heavy lifting on these microcontrollers. It just needs to be fast enough to do whatever thing you're asking it.
Yeah, and be able to talk to the hardware you need to talk to is the other big thing, right? Yep. Totally.
So Esperino is kind of like exactly like you said. It's got the JavaScript environment, but it also has like the hardware half of it. So like it exposes, like when you're dealing with microcontrollers and hardware, there are these things called GPIOs, general purpose input output. Basically, when you want to raise a particular line high or low, that's all exposed in Esperino as JavaScript things that you can do. You can basically. So all I really did was I reused that and basically got it so that you could basically compile ClojureScript down to that.
Gotcha.
Yeah, it was that. That was about so that you can see that that's mostly an effort about trying to cram it in there. Not trying to do anything fundamentally new. It's mostly just like taking these existing technologies and gluing them together.
Yeah, but that's engineering.
Yeah.
Right. It's funny actually. Sorry, I'm gonna wax. I'm gonna go on a tangent for a second.
Yeah, okay.
A little bit. So like I know a bunch of our listeners are software people, and I can't remember if I've talked before on the show or not. Maybe I did. Like this notion that we have as software people that we are inventors, right? Like there's this idea that we're outward like doing new stuff. You're not doing new stuff. Hardly anybody is doing new stuff. And in fact, your job is not to do new stuff.
Exactly.
For the most part, right? It should really be engineering. So at work, we call our software developers, we call them software engineers. And it's quite intentional. I think the idea that in my mind, I'm making these terms up. I don't claim to own them, but my definitions for these are, that engineering is the art of navigating trade-offs to achieve some outcome, right? Understanding your materials properties and, maybe navigating cost or time or, material strength or whatever. And I think that what we do in software should aspire to that, to engineering, rather than to computer science, right? Where science is, more oriented towards discovery or like understanding the nature of the problem space, right? Or
Yep.
description of the world, and we shouldn't be doing that, right? Like I'm building in the place I work at. We do ad software. We have an ad server. I'm helping to build an ad server. That's engineering. That's applying existing materials and techniques and algorithms to create a system that navigates the trade-offs appropriately. So anyway, I don't even remember why I got off on that tangent, but like I think what you're talking about, right? Like it's almost like you were a little bit defensive around this isn't new, it's not discovery.
Oh, okay. Yeah.
And I think that kind of falls a little bit out of this
Yeah.
proclivity we have in software to be like, no, you should be the inventor, the sole developer, the hacker who's out in front, like making brand new things. And there's not only nothing wrong with, recombining existing things, it's actually great to be good at that. And I think you have done this before to great effect, right? The way I ran into you way back in the day was maybe it wasn't this, but it was something you were doing around that time, was you were working on kind of unifying some of the Mac technologies. I think it might have been Swift. Remind me if I'm wrong, with some of the Clojure stuff. And it was great, right? Like you were combining chocolate and peanut butter, and the result was awesome.
If I remember right, at the time I was trying to get Clojure to run on mobile devices. That's all I was trying to do, really. Right. I was trying to compose these two separate things together. To make them work.
So it's like your superpower. You're doing it again. It's great.
I'm good at cramming stuff together.
Yeah, I think that's engineering, right? Like I think that's engineering.
Yeah, my son is learning how to program now, and he's at that point where he's learning some Java, and he shows me his program. He's like excited and shows me what it does. But then he'll show it to me, and he's like, "Look how big my program is! It's like 1,600 lines." And my response to him is like, "Can you make it do the same thing but with less code?"
Right.
And he has no clue where I'm coming from when I tell him that.
Right. Code golf is a new concept to him.
Yeah. It's like he and I remember being that way when I was a kid. It was like, oh wow, look how large my program is. It must be, look how fancy it is. He's still there too.
Yeah. No, that's a wonderful. So my older daughter was learning Java for a little while in school, and it was super interesting for a number of reasons, not least of which was me having to like completely bite my tongue and say, around things like, well, okay, I happen to think there's a way better way to do what you're doing, but that's not the point right now. Like you're making the little dude move around on the screen. That's awesome. Enjoy that, and don't have to get caught up in all of this other technical stuff or philosophical stuff that I so easily, fall into spewing.
Yeah.
Cool. Yeah. So how's that all going? Like, are you where you want to be with it, or is it still kind of coming? Because I saw some pictures.
Yeah. So one thing, that whole ClojureScript board that I made was so it works, but we're not gonna, like at work, we're not gonna be using it. We're not gonna be putting things into cars anytime soon that have that are driven by ClojureScript. It's not fast enough, and part of what we need to do at work is we need to give libraries to other people to use to build their systems, and they're all going to be doing stuff in C or maybe Rust or whatever in the near term. But for me, it was all about learning, and a big part about that board that I learned was so once I made that board, I wanted to make it so that other people could mess with it themselves. So there's this site called Tindy that I threw it up on, and people can just get it and buy it, or they can make their own. And what I found was when I started making a lot of them, that's where you start to see the interesting failure modes. And I'm so happy that I got to build I built 100 of these things now, so I could see what it means to get to that scale where you're like, and that's not a huge scale, but it's enough to start to see oh, here, this thing keeps breaking over in this corner of the board when you make it, or this part over here, if you don't, so part of what you have to do to make PCBs is you have to there's a few steps, and one of them is you put solder paste down on the board, and then you put the components on the solder paste, and that is something that you almost need a project like that to give you an opportunity to do it over and over and over again until you get it right, because the way the solder paste thing works is you have this stencil and you kind of squeegee the solder through that stencil onto the board. And what you don't learn right away, or at least it took me a long time, is that you don't want to squeeze it with a lot of force, because when you do that, the solder just kind of squirts out underneath the stencil onto the board, and it makes a mess of things, and you end up with like solder joints between, where the pins would be. So for me, going through that, basically having an opportunity to make quite a few of them gave me, the chance to like have a reason to do it over and over. Because if I was making something for myself, I wouldn't sit here and make, hundreds of them. And actually, as a fun aside, I have been having my daughter do the component placement.
Yeah.
And because she can see clearly. I can't see that well.
Yeah, no kidding. I mean, you and I are about the same age, and it's like, no way, man.
Yeah. But it's, that's just all of that stuff of like the little subtle things that could fail when you're doing that kind of stuff. You have to make quite a few of them to actually see it and learn. For me, I'm hard-headed. I have to like, oh yeah, don't do this, do that instead. And I have to like make enough of them to see that happening.
Yeah, it's so interesting just to think about what that means to be, like a solo maker working in a hobby mode, and what does it mean in terms of, should I be looking for opportunities to do more of a thing? And for me, actually, maybe not more than other people, but certainly more than I used to. I'm just interested in everything. I feel like, like I've added metalworking to my woodworking, and now electronics as well, and all this other stuff. And to some degree, I think I'm kind of robbing myself of the opportunity to do what you're talking about, and to really, if you go broad, you can't go deep, I guess, is the thing, right?
Oh, okay, yeah.
But I don't know. I mean, maybe you just have to choose, or you can alternate, or what. But I need to reflect on that a bit more and think about, is there something I should be trying to make 100 of, so that I can gain that insight?
Yeah, because I wanted to just learn. Well, I wanted to, for some reason, I want to be good at doing this, whatever it is, And one example of that, another concrete example, is when you go to make a PCB and you've got the solder and the components on there, then you have to do this thing called reflow, where you're basically melting the solder and getting. So what you can do that with, like, you can use a hot air gun to, like, and I did, like, Bill Hurd, he basically made a reflow oven for me, but he didn't deliver it to me until after I had done like 50 of these things with hot air.
Was that on purpose? Like, he was like, no, he basically, you must walk the path.
The term he used was, what was that movie? The Karate Kid movie, where the kid was doing the wax on, wax off.
Yeah, totally. Mr. Miyagi.
He was doing that to me. He was like, he wanted me to learn, like, well, when you're using hot air, you don't quite have even temperature. Like, oh, come on, just give me the reflow oven. But it was good for me to learn that way. And then once I had the reflow oven, I would make other mistakes. Like, the temptation is to say, like, oh, I can fit 10 boards in that reflow oven. Let me do them all at once. And that fails because the reflow oven can't drive the temperatures properly when it has that much thermal mass in it. So it's that the only way to learn is to do that and fail. You're like, I learned the hard way, and now it's like, okay, I can do at most 4 boards at a time that way. Maybe 6. So that's the only, that you only learn those things when you're doing quite a few of them, and for me, I'll go quite a long time between, like, making some of these, and I'll have forgotten.
Yes.
It's almost like I need to make notes for myself. Like,
oh my God,
I need to put a little yellow sticky, like, don't squeeze the solder paste too hard. Don't put 10 things in the oven.
Yeah, no, that's one, I feel that one acutely. Like, when I walk up and make the same
mistake you've made
again.
before.
Absolutely, yeah. Yeah. Oh well. It's good. I've said this before. I have a sign on my shop door that says "slow." It's like a traffic sign, and it's really my reminder to.
Yes.
You know what I mean? To just kind of, I know this is an overused phrase, and I've said it before, but, like, be in the moment, right? Enjoy the process, enjoy the journey, and if you make that mistake, go, it was still a day in the shop or an hour in the shop.
Yes, I've felt that. I remember, and I still have this in me, where when I'm making something, I feel like I need to complete it within that day or something.
Yes.
And it's only like maybe with maturity that you allow to projects to take their course over a week or weeks.
Yeah. Yeah. You'll make yourself nuts, right?
Yeah. And I will, it's that slow idea is very good, because what I'll do, and I think we all do this, is I'll like cut corners and try to get it done quickly. And,
yeah, you stop having fun too.
Yeah. There is this anxiety that goes along with it. There is. Yeah, that's weird.
Isn't it?
Yes. It's like you almost have to like play a mind trick with yourself and just say, slow down. And like exactly like you said, it's the process. And another thing that's kind of related to that is if you get like test equipment or test gear, and this also was true for me for things like getting into astronomy with telescopes and whatnot, or anything that you can buy. Or even if you think about like when you were a kid and you would buy like a stereo system, I would always want the best, the thing that was perfect. And I've gotten to an age now where I'm like, oh, that cassette tape sounds the way it does because of certain physical properties. And I'm like, I can accept that now. And I just accept it as it is. So like a lot of things that I guess in my maturity, in my older age, I'm more willing to accept less than perfect things that are, not done quickly or not the most expensive thing you could have purchased, because it, it gets the job done, has it. And in fact, if it's not perfect, you get to see the physical flaws that make it behave the way it behaves, whatever that thing is that you're dealing with. So like if a concrete example might be a telescope, and it might have like those, what are they called? Achromatic aberration, like where you get like rainbows basically when you're looking through. Yeah. For me, it's like that kind of thing used to bother me. I'm like, I don't want that. I don't want rainbows to be in my telescope view. But now I'm like, oh, that's the way the universe works. You end up with rainbows when the light interacts in this way. And
that's super interesting.
It's all about your perspective on things, and it's exactly like you said. When you're building things, you need to slow down and enjoy the process of making it.
I think it might be a little bit. I think it might be a little bit behind you on the maturity curve on that this last one. That's one that I know I definitely still struggle with a little bit. Is this notion of, accepting not only just, you're not talking just accepting compromises. Like, I don't have an infinite amount of money, so I can't buy the best thing. It's not even that. It's like being okay with it, right? Like being like fundamentally okay with the trade-off, with the suboptimal. That's super interesting.
Yeah. It's so I've started getting test equipment when I'm doing some of this electronic stuff, and you have to be careful because this stuff can get to be very expensive. If you want to buy the latest and greatest spectrum analyzer, I'm not spending 10 grand on something like that. Maybe maybe if I get the company to pay for it, but this is stuff I'm buying with my own money. So I'll buy something from the 80s that has certain characteristics, and I'm like, oh, for me, it's like, this is the way spectrum analyzers used to work in the 80s. They had certain capabilities or bandwidth to them that, and I kind of, I'm enjoying seeing those aspects of it.
Well, it helps that we're from the 80s too.
Yeah.
Sorry, I jumped on you there. Go ahead.
No, it's I don't know. It's hard to describe this thing. It's kind of like we all have retina screens on our computers these days, and you can't even see the pixels anymore. But like, yeah, if I ever work with a screen with pixels, I'm like, yeah, that's the way they work.
Yeah,
they have pixels.
Every once in a while, we'll see a movie or something where they'll show a video game from 1987 or something like that, and one of my daughters especially will turn to me and say, "Did it actually look like that? Did it really look like that?" I'm like, "Yeah, it really did."
Yeah.
Totally. Well, cool. Well, I know we have one kind of closing question we want to get to yet, but I don't want to close things down. If there's more stuff that you think we should talk about here today, we can always have you back on and talk again. I always enjoy talking, and we can do it again. But anything else you want to talk about as we start to wind down, or?
No. The closing question might be good. I was starting to think along those lines anyway.
Yeah. I find that we often naturally navigate our way towards advice over the course of the show. I think it's a natural outcome of having interesting people on to talk about things that they care about. But I will throw that question to you then, since we appear to have arrived at that point, which is, hey, Mike, I would love to hear a piece of advice from you. Could be advice you've been given, or advice that you like to give, or you think should be given about anything. It doesn't have to be about electronics or whatever. Just always interested to hear a piece of advice.
Yeah, and so for me, the advice comes about what we were just talking about with the whole electronics things and learning, which is the way I would describe it is, for me, the whole electronics things seemed to be an area that I couldn't go to in my mind. Like it was partitioned off, and I just, I'd always knew that I knew a certain set of things, and this whole electronics thing to me was like way too different. And I had this mental block with going there. So my advice is basically don't do that, basically. And also, like, if you have something like that, like picking up a guitar and trying to learn that, any of these kind of things that you find mentally difficult to jump to, they're going to take a long time of failing or not understanding, to the point where you can, start to actually feel like you're able to make progress on those kind of things. So that would be my advice is, and especially like if you think you're too old to learn something new kind of thing, like you always can pick up something. Like for me, this is almost like taking on a whole second career kind of thing. It's like even affecting my identity to that level of learning that. So my advice is like, you can do it. And I had gone through a couple of decades identifying as a software engineer, thinking that that's what I do. And thinking that things outside of that it would take, like, maybe one example of that might be like, oh, hey, Mike, if you're going to do electronics, don't you need to go get a degree in that? Right. And what it took me a while to realize is, like, I've been watching YouTube for about 4 years now on electronics, which is about the amount of time it takes to get a degree. And I probably,
that's a good point.
It's like, I've been thinking about this subject for about the same amount of time that when I was a kid learning mechanical engineering, getting that degree,
Yeah, that's a good point. Yeah, especially considering how little attention I paid in class at times, right? Yeah, no, I really like that a lot. So I would maybe boil your advice down to when I think about it, I think when I hear myself, I could say I could never, right? Like, oh, I'll never be like really good at the bass or whatever. That's like a warning flag, and you're saying that that's a sign where you may have, mentally framed yourself right out of doing something that you might well enjoy. Because I mean, clearly you are super enjoying electronics. It's a thing that you at one point said to yourself, oh, that's not accessible to me. And not only was it accessible, but it's become really important to you. Yeah,
there is this, there's this mental block that you might have, or there's this, if you think about it in terms of like a concrete thing, in terms of like you're driving down a road in your car and there's a mountain in front of you, and you're like, I can't drive over that mountain. But of course you can, right? For me, electronics was kind of that way. I'd look at a circuit board and I'm like, there's no way I can understand that thing. How can, it looks so complex. And that to me was a big enough mental block. Like, I would never understand that. I don't know how those people can grok that kind of stuff. And all it takes is watching YouTube for a couple of years, and you're like, right. And you start to pick it up. You're like, this stuff that I see people saying over and over again is starting to make sense to me. Yeah, totally. Yeah. Awesome. I love it. That's great. Yep. Always get such good advice from our guests. I love it. Yeah. Well, this has been super fun. We are going to have to do it again. I really appreciate you taking the time today to come on and talk to me. It's always good to catch up with you, and what you're working on is really, really interesting. So thanks a boatload for coming out and hanging out with us. Thanks for having me, Craig. Yeah, absolutely. Anytime. We will do it again. We'll wrap it up there, though. This has been Get Smarter and Make Stuff. You have been listening to Get Smarter and Make Stuff. I'm your host, Craig Andera. Visit the show online at getsmarterandmakestuff.com. That's all spelled out, all one word. Go there to subscribe to and comment on the show, read the blog, view the gallery, and find a link to the Get Smarter and Make Stuff YouTube channel. Come on by. We're also on Twitter at Make Smart Stuff.
If you enjoyed the show and feel like sharing with others you think might like it too, I'd certainly appreciate it. Thanks for listening, and see you next time.